What's up, guys? V.I.F here, coming back with another music lecture for you guys, just like you all asked for. And today we're going to learn about serialism, 12-tone rows. You might be asking, what is serialism and why would I ever use it? I can assure you there are a few good reasons to include serialism in your musical vocabulary. Let's say you're writing for a film, you want music to be scary, right? What's scarier than using all 12 tones of the chromatic scale in your melody? Maybe, the current state of pop music scares you away a little bit and you just want some different flavors to use. You don't want to be stuck with that same harmonic formula. And finally, serialism is an interesting and unique way to extract a lot of musical ideas from a very small set of information, basically just a set of numbers. Before you right now is my very own serial composition, music. There are only 12 tones in it, but right around here, it starts over and goes again. And you'll see that the octaves are changed and the rhythms are changed, but the order of the tones is the same over and over again. As you can see, that last part is not serialism, it is just a little tag at the end that I thought makes a nice conclusion. Anyway, you're probably wondering what all these numbers are down here. Let's start with this. This is a clock face. You could also call it a Cheerio because we're making cereal. We're going to call C 0, C sharp or D flat 1, and D 2, and so on and so forth until we get all the way up to 11, which is B. And we're going to do math to analyze our composition. So when we get a solution of 12, we're not going to call it 12, we're going to call it 0 because that's our 12th number. And if we add 2 to 11, for example, we're just going to go around the clock face. We're not going to call it 13, we're going to call it 1. Now we're going to start with the prime form, or P0. The prime form in serialism is basically the original musical idea. On our clock face, that translates to 0, 7, 5, 4, 2, 11, 6, 3, 1, 10, 9, 8. If my musical idea started on a D, we would have to transpose it down 2 tones, 1, 2, to get it back to C, and that would be our prime form. All prime forms start on 0. But there are transpositions of a prime form. For example, P2 starts on 2. And to find your P2, you take your prime form, you add 2 to every single tone. So there are 12 transpositions of this form right here, including this. Then there's the retrograde form, or R0, which is just the prime form backwards. There are also transpositions of the retrograde form. For example, to get R4, we just add 4 to every number in the retrograde form. Then there's something called an inversion. An inversion in serialism is where you go the opposite direction on the clock face. So instead of starting by going from 0 to 7, we're going to count from 0 minus 7. So instead of going 0, 7, it's going to go 0, 5. And as you can probably guess, we can transpose I0 to I1 or 2 or 3 or 4. There are 12 different transpositions of the inverted form as well. And finally, we have retrograde inversion, or RI0. This is the inverted form backwards. There are 12 different transpositions of RI as well. So you're probably wondering about this huge box with a bunch of little boxes inside of it. This is a 12-tone matrix. It sounds fancy, but it's a helpful tool for us to more quickly find all the transpositions of all the forms. We start by writing the prime form across the top row. Then we write the inverted form, I0, along the first column. We do this by subtracting each of these numbers from 12. From now on, we have a very simple task. Add every combination of these numbers. So for this box, we're going to add 5 and 7. For this box, we're going to add 5 and 5. And just pick a random example. For this box, we're going to add 6 and 11. That's going to be our magic trick. We already have a head start. We know that the sum of these combinations is all zeros because we subtracted these numbers from 12, which is 0 on our clock face, to get these numbers. Then all we have to do is add the rest, and remember to use the clock face. So for 7 plus 7, we're not going to say 14 because that doesn't exist on our clock face. We're going to say 2. Look, I made a 12-tone matrix. Took me what? Like 10 seconds? And as you can see, we did do a magic trick. We got all of these middle numbers, which gives us every different transposition of every type of form of this order right here. So, as we already said, this is our prime form. Every time we go from left to right, those are transpositions of the prime form. And obviously, going from right to left, it's backwards. So these are all the transpositions of the retrograde form. And now all of the up to downs are the 12 different transpositions of the inverted form. And finally, going from down to up is the backwards form or retrograde of the inversion. So now we have all of our P's, all of our R's, all of our I's, and all of our RI's. We have all 12 transpositions of every form. In other words, I hope you have a lot of free time because you got a lot of material to work with here. And it's all derived from this simple idea right here. And that is how you make a 12-tone matrix. And you are ready to start your serialist composition.